Hey, I'm Alex. I lead the serverless product here at fal. Today I want to show you some of the updates we've made to the serverless product over the past 3 months. For those that don't know, serverless is the inference engine that powers all the models on the fal marketplace. So all the models that you're calling through the model API, under the hood, they're deployed using serverless. And serverless is this inference engine which handles auto-scaling, queuing of requests, error handling. All of that is packaged into this kind of serverless product. And in addition to that, we have this whole dashboard to basically give full observability, insights, and debuggability into these apps that are deployed on the marketplace. Serverless is something that we've been dog feeding for around 3 or 4 years, as we've been deploying these models on the marketplace. Since the past kind of year, this has been released as a product to external enterprise customers so that they can deploy their own custom models or proprietary workloads that need to run on GPUs and also need, high reliability, the ability to scale to thousands of GPUs. We have B200s, even B300s, H100s, RTX 6000s. These GPU machine types, you have a full availability when you're deploying your app. So if you need high production quality workloads, which can be performing with high reliability at scale, then fal Serverless is the product that we've been building for ourselves to make that work. Over the past kind of 3 to 4 months, and even beyond that, we've been working a lot directly with bigger enterprise customers. And one of the biggest kind of features or kind of requests that we hear about is this kind of need for granular and detailed observability into their apps that they deploy on serverless. So we've been prioritizing adding features that give that observability into the app. So, today I want to walk through, some of those kind of new features, those new pages. They cover everything from new request pages to logs to cold start and analytical breakdowns, all the way to, kind of a new notification system to get paged on alerts as soon as errors happen. So yeah, let's get straight into it. So the first kind of main page or analytical component that we've integrated is this kind of new Aggregate Analytics dashboard that you see as you enter your serverless apps page. And specifically, a lot of customers end up deploying tens of apps on serverless. Many different apps could have different functionality. They could all be part of the same pipeline and together work together to, execute requests. Or you might just have a large number of models or workloads that you need individual endpoints for separate applications. What we wanted to introduce is this kind of aggregate overview that lets you quickly see insights across all your apps very quickly. And you can see at the top of this apps page is a set of components. So for example, here in my kind of test team, I'm seeing all my top apps over the last 6 hours by total requests. I can also see, the distribution of GPUs across all my apps. Here, for example, I have an L40 machine type, which is the largest SKU of GPU utilization. I also have RTX 6000s, B200s, H200s, and H100s. In addition, often you could have CPU apps. So you can also see the distribution for, large, medium, small CPUs. Below this, you can also then see a set of kind of timeline statistics. For example, here we're seeing like the breakdown of requests by status code across all my apps. Request traffic, the requests per second. And then below this is a kind of stacked request chart, which lets me see, which apps are contributing to the most requests for, my combined service usage. We've also improved the way we, organize and present apps. What you'll notice is we introduced this kind of list view. And this was something that just makes, the display of apps more compact, especially when you have, tens of apps that you need to manage. In each of these kind of app components, you will see different metrics so that you can very quickly scan across apps and identify, which apps have a large number of runners. Maybe they have a high error rate, which needs to be looked into more. And on the right, you can see at a glance the kind of request breakdown in terms of status code across time for each of these apps. Another useful feature is the ability to group apps in a certain way. So when you have a large number of apps, you might have maybe video apps or image apps or any kind of modality, or there might be some other way that you want to label an app. So we've added this tagging system, which lets you do that. So what I can do is if I want to go to, let's say, this video upscaler app, maybe I want to label this as an upscaler type or tag. So what I'll do is I'll create a new tag And I can choose a color. And then this is now added as a tag. Maybe I also want to do another app. For example, maybe this app here, which is real time, I want to tag as real time. What this lets you do is quickly filter to those tags. So if I want to see all my real-time apps, I can then filter to these apps. So this makes it just easier to scan through large numbers of apps, which again is something we've seen happen for like our bigger customers. Often they need this kind of organizational management. So overall, we've improved this whole like landing page for servers so that you can better organize, better quickly see at a glance errors and metrics across all your apps. And then if needed, you can then drill down to any specific apps that need to be further looked into. Next, I want to talk about a new page that we've added in the specific app overview pages. Let's go into the WAN Video Gen app. And we can see on the top here, we have a new kind of requests page. So one of the main things about observability is it needs to be very fast and seamless to find a root cause of a problem. And typically, users often think about this from a request level. Is a request taking a long time? Is there a specific error? What error is it? And we also think that it's important to make sure that the UI and the user experience getting to that root cause is as seamless as possible to use. And this is where we decided to introduce basically a timeline component at the top of this new request page. And this request page aggregates all the requests across all your endpoints for a particular app. When it comes to this timeline view, what you can see is it's a stacked timeline chart where, in the back, you have kind of these error bars, all these kind of request bars, which are broken down by status code. You have success, user errors, and regular errors. Overlaid on that is two lines. So one of the lines is the P90 for request startup, which correlates to effectively cold starts and queuing times. And then the purple line is P90 for request duration. And that corresponds to just, once an endpoint is actually executing on the GPU, like how long is the time taken to execute on the GPU. So to make this very frictionless, what you can do is if you go along the chart and you notice, let's say, a spike in request startup, you can pretty much just drag and filter to narrow the time filter for all your requests. So now I filtered to that spike. And again, if I want to, I can go into, even more zoomed in view. And here we can see we have around 4 or 5 requests here where the startup has spiked. I can then sort these requests by one of these metrics. So because I'm looking at the request startup spike, I'm going to sort by request startup and then by the slowest first. And we can see that the slowest request in terms of request startup time, this had a crazy 2,500 second startup time. Again, this is just a test app, so it has these kind of crazy values, but this lets you effectively quickly, from aggregate, go from this collection of thousands of requests to then narrowing it down to a particular request that has some sort of spike in a metric or an error. And then from then on, you can then drill down into this request. So I'm clicking into the request and this opens up the request side sheet. And on the right, I can then see the full timeline for that request in terms of it was submitted to then it entered this cold start phase. And then this execution time was actually only 25 seconds. So we can see here this cold start is contributing to a big part of this kind of end-to-end latency here. And this is useful because, when customers are debugging with the engineers at fal, often we work very closely together. Sending specific request IDs helps us help debug much faster. So this is overall improving the debugging experience for both fal and also for you. And again, once you have this request, then you can look at the inputs and outputs and also get the filtered logs for that request. And filtering by requests is a way of removing and distilling the noise to get faster insights into what's going wrong. Again, coming back to this request page, if you do need to search for a particular request ID, you can do so. If you need to filter to a specific endpoint, some apps have many endpoints. It can be useful to filter to an endpoint. And in addition, if you want to just quickly filter by errors, you can do so. By using the status filter, we can see this timeline chart filters by those errors. And again, you can basically sort and see all those requests with a specific error. We've also introduced more granularity in terms of what an error is and what's displayed on the user interface. We've added basically this notion of an error type, which breaks down into a kind of keyword description, what was the cause of an error. So we can see across these particular requests, we have an internal error. You can find the full list of errors on the docs, specifically on the error types page. And this will basically show you that full list as a reference for the error types. This is under the model APIs, errors section under request errors. So you could see that, this internal error was what we saw, but across different status codes, there are other more specific error types, from request timeout, startup timeout, to runner specific errors, such as a disconnection error or a scheduling failure. So overall, we've added this granularity and this ability to very quickly filter and sort on the request page, so you can go from a high-level aggregate of all your requests to drilling down into specific errors and spikes and latencies. And from there, you can drill into a request, look at the logs, and then find out exactly what's going wrong with your app. We've also made some bigger changes to just the general analytics page. So for this Flux LoRa app, we can go to the Analytics tab. And what you'll notice is we have a kind of large set of new kind of analytical components with much more granularity. When it comes to debugging, your app, it's also important to have very detailed and precise visibility into the key metrics that matter to you. Again, many of our bigger customers typically start with a POC with fal, where they'll be measuring a specific success criteria. This could be latency, maybe P90 latencies if you care about tail end, or it might be error rates, or it might be specifically cold starts. Given this need to validate certain success criteria, we wanted to build an analytics page which makes it very easy to identify very quickly any of these metrics. If you need more detailed breakdowns, you can then follow through on the logs page or the request page to get more detailed insights. Coming back to this analytics page, the first thing is, we can aggregate all of the analytics across all your endpoints for an app. But if you want to filter to an endpoint in a specific app, you can do so. I'll just filter to the kind of root endpoint for Flux LoRa. And we introduced also basically a kind of interval for bucketing the data. Previously we had quite large buckets, but in order to increase precision so that you have much more precise visibility, we've kind of made these bucketing options there and available. So in 5-minute buckets, I can very clearly see a precise, detailed overview of all these different analytics. So at the top, we can clearly see the execution P90s, and then on the right, also the cold boot rate, which we'll talk about in a minute. You have a breakdown of the status codes, and this is actually further broken down into those error types that I mentioned. So you can clearly see that in this case, we have a large percentage, a large success rate for our app, even 100% or rounded up to 100%. But we also see occasionally we have a small number of connection errors and client errors. So these are error types, which I mentioned earlier. If you want a kind of broad overview of the end-to-end latency, which includes, request startup and request execution, you can clearly see that here on this chart. And this shows you everything from the P50, the median case, to the P99s for end-to-end latency. And then below this is, again, like a breakdown of end-to-end latency. And again, this is very important because it helps distinguish the attribution to latency from cold starts and queuing from basically the execution duration, which is when a request is actually, running on like a warm GPU and actually executing your endpoint. And the first kind of component, we can see startup breakdown. And this includes everything from the queuing times to, the cold boots, where GPU has to spin up. And again, if you want to see a more granular breakdown, you can open this breakdown, and then you can see, across queue times, across cold boot times, what these kind of values are across different percentiles. And then again, you can see your kind of cold boot rate over time. And in a sense, cold boot is referring to requests which are taking longer than 1 second before actually executing. So it could be contributed from the actual spin up of the GPU, or it could be partly from queuing. But this gives you a sense on how often requests are actually landing on warm runners straight away. So if you're seeing a high cold boot rate, that would indicate that many of your requests are not landing on warm runners. And that could be a case where you want to actually set your minimum concurrency or the minimum number of GPUs to a much higher value than what you have. And when you do that, you're basically saying, okay, I want to have a pool of GPUs up to this min concurrency value that are always on 24/7 and therefore are going to be warm. And then they don't need to cold start after their first setup. So that will reduce this cold boot rate. For customers who are seeing this and who need very kind of reduced cold starts, we offer, reserve discounts for annual commitments So you can get very good pricing, very competitive pricing when you reserve a baseline number of GPUs. So this analytics page helps you get insights into that. And again, if you do need to break this down further in terms of you want more precise visibility, we've again transformed and transferred that functionality and that user experience of being able to click and drag into a specific region to basically filter to that timeline. So you can very quickly zoom into specific incidents or spikes in these charts. And again, if you do notice that the cold boot times are high, then you can work with our optimization team to reduce the times in which, your app and your runners are spinning up. And this typically is something that happens in the setup function of your app. And this is where you're loading model weights. You'll be loading model weights from our data volume, which has multi-layer caching. But there's some other techniques that you can use to optimize your cold starts. And you can find this again, all on the docs page. So if you scroll down you can go down to this optimization section. You can see two kind of guides on optimizing for cold starts and optimizing for costs. And as I mentioned, there are different techniques. One of these is, using Torch compile to store compiled artifacts, which can then be stored in our kind of persistent data volume so that new runners that are spinning up, they can basically pull from this data volume without having to recompile. In addition, we have Flashpack, which is an open source library that speeds up model loading. There's a set of scaling parameters that you can adjust to improve cold starts. An example of this is concurrency buffer, which schedules or provisions GPUs and runners ahead of traffic. So you can basically start warming up ahead of the demand. It could be something that is kind of linear, or it could be something that's completely proportional to the amount of traffic that's coming into your app. So you can basically tweak these bells and whistles for scaling parameters. And going back to the analytics page, you can observe the changes to latency, cold starts, and utilization all through this dashboard. So you can go through that iterative process and optimize your app. So yeah, we basically wanted to make sure that the analytics pages has all that information and that level of precision and that ease of use to make that process of observing what's going on to the app, to then actually making that an action point and optimizing your app, that kind of circle as efficient and seamless as possible. We've also made some updates to the runners page so that debugging from the runner point of view is a lot easier and simple. So firstly, when you go to this new runners page, you'll get a breakdown of your runners in terms of the different states that they're in, from running, pending, Docker pull to draining. And then in addition to that, you can see that we've added some new kind of columns. So typically you want to, again, as part of this cold start analysis, you want to understand from a runner level point of view, how long is it taking to set up this runner to the point that it's able to serve requests? So you'll see here on this row that at the top we have time for pending, which is the time taken to actually allocate a runner from the fal infrastructure point of view. And then, once a runner is allocated, typically it will pull in a Docker image, which is either cached, or if it's not cached, it will have to do a full pull. And you'll be able to see whether it's cached or if not, what those times look like for the Docker pull stage. Then it will run up your setup function. And this typically is where you load model weights onto GPU and often contribute significantly to cold starts, as mentioned earlier. And then you get your total kind of cold start time. If you want to sort these runners by cold start times, you can do that. And again, this comes back to this, main product value that, we're trying to provide for all of these improvements, which is, how do we reduce the friction and the time taken to debug and identify, the extremities that occur in your app. And that's typically very large cold starts or very, slow latencies. So these sorting abilities and this information that we provide enable you to basically drill down from, again, a large set of, let's say, requests or a large set of runners to a specific request or specific runner that you can then debug and get information to then optimize your app. In this case, I'm seeing, this was a runner that had a very long cold start of 106 seconds. So what I can do is I can then click into this, and this new runner size sheet gives you kind of all the information you need. So you've gone from aggregating all these runners to then drilling down into a specific runner. And now I can then look into this runner and see exactly what's going wrong. So the first thing you'll notice is we have this kind of cold start timeline, which will show you across the various different stages as a runner spins up, what those times across those stages look like. So you see the pending time, the setup time. So in this case, the interesting part is we can see that it's not the setup time or my setup function that's contributing to the cold start. In this case, it's more an allocation time. And this is really important because we are using B200s. So I'm fully bursting into the shared pool of GPUs of B200s that other customers are using. So when there's capacity crunch or there's a high volume of traffic, across different customers, it can take longer to allocate B200s, and the same principle for any other more scarce GPUs. Typically, one of the best solutions to this is to have a reserved amount of capacity. So you might have a reserved pool of B200s where you'll never have pending times and you'll never have setup times. You get that guarantee in performance for those reserved GPUs. And this is often very useful as well. When you have a reserve pool, it can make it a lot easier to have, more predictable, economics, more predictable performance, especially when you're trying to forecast over a time horizon of a year. And if you need enterprise SLAs, this can obviously be a very important part of that. And reservations, again, we can also look at the performance of specific GPUs, maybe driver versions, or any other specific OS level requirements or hardware requirements that are giving the best performance to your app. Then we can then ensure that the reserved pool of GPUs are optimized specifically for your app and use case. On this runner's side sheet, you can also see, we have a number of tabs. You get insights into the telemetry, CPU percentage, memory, VRAM, usage over time. And again, part of this drilling down and removing the noise is that these logs are then filtered to that specific runner ID. So I can see the full timeline of logs for this particular runner, scrolling down from when it started and when the GPU was spinning up to when it was actually attempting to execute requests. And we can see here there's some errors in terms of CUDA out to memory errors that, makes it very easy to see exactly what's going wrong. So I've gone from the runners page to very quickly identifying an error through the logs as well. There's also this connect tab. And I mentioned this in a previous video, but you can also SSH into runners through the command fal runners shell, where you paste in your runner ID into the command. This is only available for active runners, but it lets you basically get full access to the runner so you can perform commands. As an example, NVIDIA -SMI is a common command where you can exactly see the driver specs and the VRAM usage kind of in real time. So this offers additional debuggability, which makes it very easy to identify if things are going wrong. Again, you can see on the top right, we also provide the error type, and we can see that this was terminated due to a runner error. If you need to also, manage runners, you can do so. For example, typically what you can do is actually click on these three dots and then you can terminate or kill runners. So we go to our video upscaler app and we go to runners, and we have these two running runners. I can actually click on the three dots and if needed, gracefully stop a runner so that it finishes its current execution of a current request, or just completely terminate a runner. So you have that level of control as well through the application UI. Going back to logs, a big theme of the improvements we've made to the product has been about taking, a lot of noise and trying to very quickly distill it down through filtering, through precise information that is surfaced through the user interface. And logs is another classic page where there's a lot of noise that you need to kind of go through and filter. From the runner point of view, you can open these logs on the logs page. Alternatively, if we just go to the logs page, we can see there's a new kind of format for logs. A similar principle to which we applied to the requests page, we've added this timeline view with the goal of making it very easy to identify errors over time, any groups or clusters of errors, any specific type of error. And then very quickly, you can filter on that timeline using the kind of drag selection functionality. If I change from live mode, the previous approach we had was that you could, for example, enter custom times. But with this new approach, what you can do is very quickly, filter by errors. And on this timeline, again, you can basically drag and select to filter to that region that is you've selected. And then when we click on this log error, we have a number of new options that make logs much easier to debug and collaborate on. So again, one of the big things we noticed over the past months working with bigger customers is that often there'll be like kind of big teams who are working together on these applications, and they need to work together to debug apps. And it's the same when they're working with fal. Like, we often offer that same support. So we need a good way for the teams internally to collaborate and also to collaborate externally to us. So we've added a few extra buttons and options here that make it easier. So for example, you can share a log line. If you identify a specific log line, you can click on share link, and then pasting this in, this will open up to that exact specific log line on that page. And we've seen that it now opens up to that specific log line at that particular point, filtered by that same minimum error. In addition to that, you can actually show what that log line looks like in its full context. Often you're going to be filtering to a specific minimum level, which will only show error logs. But then you'd want to see, okay, what does that log line look like? What is the trace back, or what's the context of that log line? And you can do the same approach where you click show in context, and that will basically open up the logs and scroll down to that particular log line. And then you can see in the context of it, what does that log line look like? So we can see this traceback over here, and that makes it very fast to debug and understand the context of a error. So overall, this makes debugging logs much simpler and faster to execute. Again, part of this kind of collaborative need that teams often have, we've also added this ability to, basically copy multiple log lines. So if you want to basically bulk select some log lines, you can then copy those log lines as a CSV and paste it either into an agent for it to debug, or if you want to share it with a team, you can paste it into, for example, Slack. So this makes it very easy to share and collaborate on. And then again, on the top, we have different kind of filters. If you need to filter by specific runner ID, request ID, or version ID, you can do that. If you need to look at specific endpoints, you can filter by those specific endpoints too. So you have all the possible filtering options that are needed to debug logs. And at the same time, this user experience makes it faster and reduce that time before you actually find errors in your app. Again, you can export all of your logs as a CSV or copy them in bulk, which makes it easy. Another really important part of debugging is basically needing to minimize that time. Maybe you're not on an application and maybe you're away from using the product. You need to be alerted on what's going wrong with your app. So we've improved our notification system so that you can be alerted through multiple channels. And even when you're not using the serverless product or the dashboard, you'll be notified as quickly as possible so that you can then debug and make sure everything is working smoothly. So you'll notice this new notifications tab, and you'll see notifications in the app itself. But as I mentioned, you can go to settings, and we do have multiple channels in which you can receive notifications. So the first thing to notice is right now, there's kind of two main notifications, which we plan to extend extensively. For example, there's a queue size notification, and then there's a 500 status code error rate notification. And again, we're trying to give you as much control and granularity as possible, so you can actually specify exact thresholds that you need to receive these alerts. So for example, here, if the queue size exceeds a certain number of items or requests for a certain amount of time, that is my kind of condition for which I'm going to send a notification. And you can then define whether you want it to be in-app, which you'll notice on these pages and also on the bell icon at the top, which you can quickly look at, or you can get it through email or through Slack. And Slack connections is something I've shown in a previous video, but you can connect to Slack, by following this workflow here. So this gives you all the flexibility that you need to get alerted across different channels. And you can do this on a per app basis. So you can either have a custom rule for this specific app. Some apps might be more tolerant to larger queue sizes or more tolerant to higher error rates. And you can adjust those thresholds to customize per app. This is all part of this kind of whole revamp in terms of being alerted as quickly as possible. And again, combined with the new improvements to the analytics, runner and request pages and logs pages, you can then go from being alerted to finding out exactly what's happening and what went wrong in your app as quickly as possible, removing all the friction that there was previously. One thing that would be nice to talk about is improvements to the developer experience. And one feature we've implemented kind of recently is environments. So if you go to your serverless apps page, you can actually access this secrets page. And what you'll notice is there's this kind of button where you can toggle between different environments. And the whole point of environments is that it helps you isolate secrets and separates the work you do during development from your main production environment and application, which is then serving, potentially thousands or tens of thousands of requests per day. I'm going to show an example of creating an environment. So first we can go back to the docs and we can start with a basic Hello World example. I'm going to go to Quick Start and then copy this Hello World example. And then I'm going to create a new app in my directory called Hello World. And then just paste this in. And then what I want to do is create a new environment. Let's go back to our dashboard. And on secrets, I'm going to create a new environment for this demo. We can manage environments and then add an environment. And let's call this demo env. And then I'm switched to this demo environment. I'm going to add a secret. Let's call it demo secret. And then for this demo environment, I'm going to call this demo as the value. And then let's go to our main environment and let's also make a new secret. Again, the same one, demo secret. And let's call this production as the value. So now we have a demo secret that exists both on our main environment and our demo environment. And then what I can do is if I go back to my Hello World app, I'm going to create an example where, we deploy this app on those two environments. And what I'd expect to see is that the demo environment application will pull in the demo environment secret, whereas the main application will pull in, the demo secret from the main environment. And we should see those two different results. Let's import OS. And then what I'm going to do is say if os.get environment demo secret equals demo. We could actually just, let's just return as part of this output to this application, the message hello world, and then this environment attribute with demo. Otherwise, we will return hello world with the environment being production. So I'm just going to remove this. What I expect is on the demo environment application that it's going to be pulling in a demo secret that has a value of demo. And in that case, it will return demo in the environment attribute of the return payload or the response payload. Otherwise, we expect that the app on the main will be pulling in the demo secret equal to production. Okay, so I'm going to firstly deploy this example, and let's call this Hello World app. I'll deploy Hello World. Okay, so this is now deploying my main production app for this Hello World app. And at the same time, I'm going to deploy the demo app with the --env at the end. So this has then deployed that same app to the demo environment. And now if we go to the playground, we will see that our app has been deployed. And at the top, we can see that there's two environments here. So we have the main environment, which we deployed, and this demo environment. If we then actually go to the playground, this is on our main environment. I'll click run. What I would expect is it to return env production. And we can see here that it's returned production as a value for the env attribute. Let's switch to our demo env. And now going back to the playground, running this, we would expect to see demo in the environment attribute value. And we see this. So again, this is how you can separate out basically the different environments during development. And it ensures isolation of secrets and makes the operational management more secure when you have multiple team members working on your application or you have many features that you need to roll out. So this becomes a much safer way of deploying apps as part of this kind of deployment process. On top of that, all the analytics and the other pages are isolated per environment. So we'll see the request for our demo environment. And if I want to switch to the main environment, I can also see that isolated request that I made. So again, this is another part of improving the deployment process and making sure all of the operational efficiencies are improved to suit kind of production workloads. So the major theme across all of these updates in this video is about reducing operational friction, being able to manage your apps effectively, quickly identify bugs, spikes in latency, and having all the information and granularity you need to debug effectively. And this has been something that we've built based on our communication and working together with these customers over the past months. So we really appreciate all the feedback, and we continue to work to build one of the best products you can find in the industry for deploying generative media apps that scale to thousands of GPUs. If you want to get started on serverless, you can just follow the link in the description and contact us. And as I said, we offer everything from optimization support to debuggability, and we take a lot of care to make sure that these feature requests are iterated on fast to make sure that the product experience is as best as possible for your needs. Today, we've discussed a lot on observability and analytics, but there's a ton of other updates that we've been making, which I'll discuss more in future videos. But if you want to dive into some of those, you can follow the changelog on the docs, which will show all the updates to the product over the past months, which we update regularly. So yeah, any questions you have, feel free to reach out, and we're excited to see what you deploy in the future.